Hi, welcome to a little update presentation. Today I just wanted to talk very briefly about the Heritage in the Crossfire project, which is based at UE Bristol and led by myself, Lisa Mol, from the Department of Geography and Environmental Management. And in these really weird times, I thought it'd be really nice to just give an update on how things are going, what are we up to, and what is happening. As you can see, we're still trying to work across a wide range of partners, all of whom are also currently in lockdown. But things are going pretty well. So here we go. So for those who aren't quite familiar with this project, our mission is to provide scientific understanding of ballistic impacts on heritage stonework in conflict zones. I quite often get asked the question, but why? This is a bit of an oddball project in some ways, but actually when you think about it, ballistic impacts are incredibly common in conflict zones, either as an act of vandalism or through hand-to-hand combat or just accidental crossfire that shouldn't have ended up anywhere near a heritage site. And quite often these are overlooked because they're relatively small. They don't draw the attention as much as the big explosions like barrel bombs that we've seen in Hathra and Palmyra. But they do actually cause quite a lot of damage. So what we are doing is trying to figure out, well, what happens when a bullet hits a rock face and how does that then have ramifications for the long-term preservation of these sites. So the easiest thing to do that is, the easiest way is to try and break a whole bunch of rocks. We actually use non-heritage rocks, so we just buy them from the quarry and we shoot them. And that helps us to really control the conditions, and we can then measure the changes in the rock structure at the time of the impact. We can have really nice video footage of the bullet hitting the rock surface. We get thermal imagery, and we can really try and figure out, what is actually happening when this bullet hits the rock face. But also, we can then use that in a laboratory setting to figure out, well, how do these damaged sites then respond to environmental stress, like being exposed to lots of sunshine or lots of salts coming through the ground, or what happens when moisture gets into these stones. And all of this gives us a really nice package of knowledge that helps us to talk to organizations that actually are very actively involved in this work, like Blue Shield, like the British Army, and like lots of museums around the world. But it also gives us a really nice opportunity to talk to the wider public about why we are doing this work and why it's really important that we understand the smaller scale damage as much as the big scale damage. So as I said, what we're doing is we're shooting lots of rocks, and you can see two nice images here. One is a stagnant image from a limestone that's been shot. On the left, you see a high-speed video image of a bullet hitting a sandstone block, and you can just see how much damage this actually does to a rock surface. It completely sort of blows it apart. Most commonly used in these sort of conflicts are semi-automatics like AK-47s, and said they can actually really punch through a rock surface. And it's not a case of what you see is what you get. Quite often what we see is lots of deterioration underneath the surface as well, like things that we can't see, fractures that are invisible. And what we also do is try and test this in the field as much as possible. And I thought it'd be quite fun just to show a couple of pictures of the team in action. This is in Wadi Rum, and you can see we're doing lots of measurements on rock surfaces. You can see me in a few of these photos, for example, on the right, taking permeability permeability measurements. And on the left, you can see one of my colleagues, Charlotte, doing lots of photogrammetry. So we take lots and lots of images of these surfaces, we build 3D models, and it helps us to sort of build up the narrative of what happened, why is there a bullet impact there, and what has that bullet impact done to the rock surface. And as I said, one of the things that's been really nice is that we can translate this into training materials. So the people who really need to deal with damaged sites can then use this knowledge to try and manage their sites to the best of their abilities. So a lot of what we're doing is trying to prevent further deterioration and then facilitate sensitive restoration. So we had opportunity to work with the Training in Action program and teach a lot of Tunisian and Libyan heritage professionals how to deal with this kind of damage using information packs we put together, but also taking them out into the field and showing them exactly how this damage resonates on these surfaces. What we also do is go to, frankly, the source of a lot of this damage. And actually, the British Army has been really good at listening to us, where, again, we're providing training. We are teaching people who are dealing with heritage, in particular, the new groups like the Monuments Men. And there's actually tons of Monuments Men garrisons around the world where, for example, the Australian, the Italian, the French, the British, the Dutch, and the American armies all have divisions now that directly deal with heritage. So we are training these divisions in how to deal with potentially sensitive sites, how to create refuges where they can actually transport the art to, so it's kept relatively safe. We talk them through environmental conditions, and we're also very much talking to them about the damage that their own gunfire might be doing. And we're trying to teach them ways of drawing the fire away from sensitive sites. And as I said, we're also doing a lot of public outreach work. So we work a lot with particularly the Smithsonian, the Cultural Rescue Initiative, and also the V&A Culture and Crisis Network, both of which are brilliant networks for heritage professionals to show, how do we rescue heritage that is in distress? And that can be things like conflict, can also be flooding. And right now, obviously, we've got security issues with the pandemic. So these networks bring all of these heritage professionals together, including our research group, and then we can use that forum to then talk to wider public about why this matters and just trying to create more awareness. We're also working a lot with NGOs, like the Blue Shield, for example, and that all, again, gives us a nice forum to pull together a lot more collaborative work on a much more interdisciplinary level. So working a lot with archaeologists, forensic scientists, the Metropolitan Police has been really interested in the sort of work that we're doing. So again, it's just a way of raising awareness, but also enhancing the research. On the left, you see a picture where I'm giving a presentation at the Smithsonian. This was earlier this year in February, and the video of that will be released on the 22nd of this month. So I'll make sure that that is distributed as well, and you can sort of hear a bit more about all the high resolution work that we're doing. Now, unfortunately, we are in lockdown as much as anyone else, and this has hampered progress quite a lot. The COVID-19 has closed our labs, which has hampered the laboratory testing. So we've got lots of samples patiently waiting for our return. That doesn't mean that we've not been busy. We've got quite a lot of active projects running at the moment. One of the data sets that we gathered just before the lockdown, luckily, was at the Royal Garrison Church, which is a collaboration with English Heritage and Portsmouth University, where we've been getting lots of material assessment done and also a lot of photogrammetry, and trying to assess the impact of a bomb that fell in the church in the Blitz in the Second World War and did quite a lot of damage. You can actually see one of the damaged pillars on the right there. We're also working on a self-healing materials project at Cardiff University. This is where UV plays a little bit more of a secondary role, but we're very much involved in this. And we've been investigating the potential use of bacteria to try and get little cracks to fill themselves up. So we're now getting the publication together for that. And we're now also applying for further work in Sabratha in Libya, together with Durham University. The first step is to try and get a thorough assessment done, which is done in collaboration with UNESCO. Just trying to figure out exactly where the damage is, how severe it is, and then we are going to assess if the self-healing materials approaches might actually be of use there. The other data that we're now processing is from the ENGINX beam time that we were very kindly awarded by the Science Technology Facilities Council, where we got lots of data on the sort of neutron level changes that we're seeing in quartz that has been affected by an AK-103 shot. So lots and lots of efforts going into processing this data now and writing that up. And we're looking at a new collaboration within UWI with forensic science to see if we can find trace metal evidence that is left on the shot surfaces. And as soon as the lab's open, we're good to go there. So this is the quick update. I hope you enjoyed it, and stay posted because there'll be lots more in the future.